Good afternoon, everyone. Welcome to Taco Tuesday, commercial style. My name is Brett Zerba, and I'm an application/training engineer with Taco. Been with the company over 25 years now. Unbelievable, unbelievable. Today's topic will be talking about some of the Taco products, KV and KS pumps, some of our vertical inline pumps. If I'm going solo today, so I need to do both the introduction and the presentation and answering the questions and everything else. So if a couple of you could raise your hand to make sure you can see and hear me, I would appreciate that, or type into the question area. Any hand waving? Oh, okay. Thank you, Brian. Good. Well, at least Brian can hear me, so that's good. And happy Tuesday, loud and clear. All right, Neil, Gabe, thank you very much. So also, as you most of you know, a lot of you have been through this before. There will be an email you will receive roughly 24 hours after today's presentation with a copy of the recording. We are recording this, and access to your PDH hour credit if so choose that you need that for your professional hours for your continuing education. Also, there are 3 handouts. There were 5, but someone mentioned that 2 of them weren't acting up. So there are 3 handouts, and they are Word documents for specifications. If you so choose to specify one of these products in some of your engineering documents. There's a KV one, a KS one, and for the bigger KSs, and we'll talk about some of the bigger KSs as we get going here. As most of you know, as I said, I've been with the company 25 years. Rich, my co-conspirator, is taking a well-deserved vacation. As most of you realize, it's nice to get away every once in a while, so he's on vacation this week. But I'm here. Hopefully I don't get too many boos because of that, but nonetheless, we are going to have some fun today. So type in your questions. Ask away when you can. I'll go back and forth to answer most of the questions. And if I don't get to all of them, I will touch base with you as we can go. Let's see, is there anything else? I think that's about it. We got almost 130 people on, so that's a good turnout for a Tuesday afternoon. Bright and sunny where I am. Hopefully it is the same where you are. Any of the folks in Oklahoma and Texas, I hope you're safe after some of that terrible weather that came through yesterday. But nonetheless, let's get going. Let's start talking about Taco's very high efficient product line, the KV and KS pumps, best in the industry. And I'll show you a nice little graph on that as we get going in here. So what is an inline pump? Most of you might know this, and now I hope everyone realizes I am talking about HVAC hydronic pumps. Okay, that's what Taco manufactures, and most of you know that and have been to our website. Maybe some of you seen us at ASHRAE. I recognize some of the names there. I think I introduced some of you folks introduced yourselves to me. So I was there out in Las Vegas a few weeks ago. How long ago was that? God, it's already been 2 months. Oh my God. Hard to believe, but nonetheless, that's what you're looking at here, some inline pumps, okay? And I'm going to talk about split or closed coupled, suction discharge or inline, differentiated by shaft orientation. So the 2 pumps on the left are horizontal inlines, okay? I'm not going to talk about those. We have a different webinar that we talk about those little guys. And I say little, they only go up to 250 GPM. Well suited for those type of projects, but nonetheless, not the bigger stuff that we're going to be talking about today. So I'm going to be talking about the vertical inlines, the Taco KS and KV model. And you can see the 2 good pictures of them right here in front of us. And on the left is the KS model, and on the right is the KV model. We put numbers after the model, as an example, 3007, so a KS 3007, a KV 3007. If you have the same impeller cut and the same motor, the wet ends, if you sat through some of our other discussions, you know what I'm talking about here. That's the casing, right? The wet end, the casing down here. Those 2 models, those 2 pumps will give you the same output. That's common in our industry. And obviously I'm concentrating on green pumps, but you could use a red pump or a blue pump, and they'd be similar in that regard. So just keep that in mind. Just because one is closed coupled and one is split coupled doesn't mean it changes as long as the numbers are the same, right? The model number and the horsepower, impeller cut, and all of that, the internals, you're still going to get the same flowing head out of it. So on the left side is the split coupled, and I'm going to show you some other pictures. I'm going to talk probably more about this one than I am the KV, but nonetheless, split coupled. What that means, and if you sat through some of our other discussions, you probably understand that already. There's two different shafts involved, so they're split, right? So you have the impeller shaft, which you can't see it. You'll see it in a different slide that ties into the impeller, and then there's a gap between the two, and then you have the motor shaft. Over here, closed coupled, direct coupled. There's different terminology in our industry. The motor shaft is the impeller shaft. So, think about maintenance, and we'll talk about that as I move forward. So I'm going to talk about the KS and the KV models, and I'm going to talk about the SKS and SKV models. I'll show you some pictures of that. Those are the Takeo models with the variable speed drive mounted right to it, or it comes with it. It depends on the horsepower, and that can be a very, very smart drive that, and I'll talk about that, or it can be a standard type drive where you input the regular signals that you would from some transducers out in the system. So again, split coupled motor drive is isolated from the system with split coupler design. Okay, so and this is a precision aluminum coupling. Some of you folks have been to our factory, and we actually manufacture that piece, machine it right at our factory. In Cranston, Rhode Island. Our headquarters are in Cranston, Rhode Island, and so what that allows is that motor piping and everything else doesn't have to come off in order to change the seal. And I'm going to talk about changing the seal when I get into further into discussions. So, many of you, if not all of you, have been through possible seal issues on pumps, and either you get the call or you're actually on the front end, the installer or maintenance guy, maintenance person. You understand that you have to change seals, and become a bear at times, but you do have access to it here by unbolting some stuff, and I'm going to get into further conversations about that. So that's one of the big advantages of this KS pump. So if you think about weights of motors, right? You got the KV, you got the KS, direct coupled, you got to lift that motor off. If you look back at this picture here, that whole motor has to come off to get to that seal. So many of my good friends that I work with that are our manufacturers reps, they don't try to quote any KVs bigger than 7.5 to 10 horse. That's their max, because the motor just gets too heavy, and it's really a little unbearable for the maintenance guy or somebody down the road. So they would turn to a KS. And then you can see the flow ranges here for the KS pump. And I want to make sure everyone understands the capacity for these guys gets up very, very high, a lot higher than the base mounted end suction RFI pumps, not the split case, right? The RTAs that we have other seminars on or webinars on, but these KS pumps can get very, very big, and for the most part take care of any of the HVAC hydronic projects you have out there. If you have one that needs bigger than that, let us know, and we'll put one on the drawing board and take care of it. Though you can kind of see the different sizes here, and on the inline pumps, a little different than the base mounted pumps. The suction and discharge are the same diameter. The flanges are the same diameter. So if you think about a 6-inch pipe, it's 6-inch coming in, 6-inch going out, or 8-inch or whatever. So that's pretty straightforward there. And then the working pressures, you can see what's standard and optional here. And we'll get into some of the materials and construction as we go here. Most probably 90+% in projects. The temperature at 250 is fine, but you can get up higher. Make sure you talk to your manufacturer's rep so you're ordering all the right components and material. If you do need to specify higher temperatures for whatever reason. And keep in mind, these are HVAC. This is for hydronic. This is to move water and maybe some glycol and some other chemicals, but not nothing crazy, right? These are not municipality pumps or industrial pumps by any stretch of the imagination. So keep that in mind. And then, for those folks out there that design high rises, if you don't have some type of way to split the pressures when you're designing the system, as you're, the pipe's got to go all the way up to the 30th floor and back down. If you don't split those pressures, you may need to get to the higher PSI. So make sure you take that into account. But nonetheless, most of us pump manufacturers, if not all of them, offer both of those standard pressures. Pretty straightforward there. And then, I think these ranges of head loss, it goes up really high, but probably, what is it, 60 to 150 might be the sweet spot range there, but nonetheless, you can kind of see all of them there. So this is the KB pump, right? You can see that it's got a NEMA straightforward JM frame motor, up to 60 horse. So the KBs only go up to 60 horse. I think they start at 1.5 horse, probably up to 60 horse. And again, you may want to, now, I think most of us can understand that the KV close coupled is going to be a little less than the KS, right? Because there's more components, right? You can kind of see that there. And again, you got to get your pricing from others or from the rep and whatnot. But oops, wrong way. So, some people do specify it for 20, 30, 40 horse and whatnot. But really, if you start thinking about it from a practical standpoint, that's probably not the best overall thought process there. It can be done. We all offer them because those NEMA motors, JM style, go up to that 60 horse at least. For fans and stuff like that, it's probably not as bad. But sooner or later, the seal is going to have to be replaced. Sooner or later. They're designed to last 7 to 10 years, if not longer. In the right situation, application, clean water going through there and whatnot, you should be fine for at least that long. You got a little flush here going through there, so stuff to consider there, but nonetheless, things to consider. And then as you can see here, the KV doesn't go up nearly as close in horsepower as the KS does, as you can see there. So just keep that in mind. But everything else is pretty much the same. Obviously, the sizes are different, the horsepowers are different, but nonetheless, this information right here is pretty much the same between the two. And again, I want to reemphasize the same model, KB, KS, with the same numbers after it in a horsepower and impeller cut, and you're going to get the same flowing head out of each one. So some basic stuff to understand there when you go. So something to consider. So here's kind of this is in some of our literature online, but it just it does have a stainless steel pump shaft. All right, so that's this item right here. It is a stainless steel pump shaft. It's a standard seal design, John Crane type 21. A standard seal design. It is different if you go to a higher pressure, right? It's a type 2, I believe, but nonetheless, standard seal design, pretty universal in that regard. And there are pressure tapping on suction and discharge, standard on our pumps, so you can put the gauges right there if you'd like. And I do see details on some MEP packages out there. And again, to reemphasize, you can get it with the 250 flanges are available. There is a casing drain. So you can drain this out, down the road if you need to. One of the really nice things about these vertical inline pumps, and not just the green ones. Obviously I'm talking about these, and I emphasize that. That, right? I work for Taco, but all of them, it's all machine mounted surfaces with tap holes. So everything's tight and machine mounted up here, even the KS or the KV. So you know what that means? In the field, there's no alignment. If you sat through some of our other discussions, we talked about the FI pumps. And you know, and obviously the split case, you have to align things in the field, right? And you know, if you get into bigger projects, probably recommend laser alignment. So it's really not right on the money, as you can only imagine. But with these there is no field alignment. It is bolted up, hard bolted, machined in place, not in place, but machined fit. So there is no alignment of these once it gets into the field. So you know, that's something to consider. Um, uh, I know it's very difficult, and you know, I'm a degreed mechanical engineer. I was on your side of the fence for many years, maybe in a different role, but nonetheless, it's very difficult sometimes to change our thought process on things, because it's always worked, right? We have the drawings, we have the details, our specs are all written that way and whatnot. But these guys here, if you specify them once or twice and you don't get any of the callbacks or installation issues, it's something to think about in there. We do offer a low-cost replaceable wear ring if you so choose on that. And I'm going to show you some pictures of our impellers. We have very high efficient impellers that have really helped us leapfrog our competitors by 2, 3, maybe even 4 percentage points from an efficiency standpoint. The process that we use, or our vendor uses to manufacture these products is quite top of the line. And then this does not come with the pump, but you can get a support stand. And one of the nice things on ours is over here, there are machine holes down here. As you can see, machine mounting surface with tap holes. So this stand can be bolted right up. So it's already there. It just doesn't float on it, right? So you can actually bolt that stand on there. So something to consider. It's in our documentation and our price sheets. But nonetheless, I think it's important to understand. You know, we're trying to give you as much education as we can on these different products here. Here's the material of construction. I'm not going to read it all. Some of the differentiations I'm going to try to point out. And one of the first things I like to point out is the mechanical seal. Okay, so standard ceramic EPT, 70–80% of maybe even higher of the liquids out there. That's going to be fine. That is going to be fine. But you start getting into some of the additives that we're seeing, and you may be seeing, or whatnot, in different areas, different projects, or whatever. Sometimes that stuff may cause some issues with these seals. And as much as we try, and the seal manufacturers try to stay ahead of the curve, things are changing on a regular basis. So there are some options here for some upgrades. And to be quite honest, I actually see some specifications out there where this is what they want as a standard. Something to consider. You know, talk it over amongst yourselves at your company. But you know, for the upfront, for the, I'm going to say pennies, but for percentage-wise, for the a little bit of it's peace of mind. Sometimes peace of mind is a big deal there. So some stuff to consider in that regard. And then this is the other probably big thing I like to point out here, is that the casing wet end is ductile iron for the 250. Chris is asking about the wear ring. You know, that's a good question. He said, are there any specific advantages of using a wear ring? And some people feel that it does protect things a little bit. So that's why it's in there. It's standard on some pumps, not standard on another. I think I think in the old days it was probably when products weren't as tightly specified or whatever on our end, it was probably more important, right, in that regard. But nowadays, I think with the more precision of everything out there and the 3D modeling and whatnot, is probably not as critical. And really, we still see it in some specifications. I think our reps still see it in some specifications, but from my perspective, I don't think there's a big advantage. It's not a showstopper by any stretch of the imagination. So our hot water pumps can become NSF 61. So you do have that possibility as well. But really the only difference, as you can see here, is you can get the wear ring. Let's see. What's the difference? No, I think it was. I don't know. Sometimes I get wrapped around the axis of what's different, but nonetheless. Oh yeah, right here. The flange is a little different on one of them. This is in our literature as well, and it's just a rating. As the temperature gets hotter, the pressure ratings in accordance with the ANSI standard B 16.1, you can see it does degrade a little bit, not that much that it's probably going to affect your design, but nonetheless, it is important to understand that. And then notice down here, if you do get into a project with high temperatures, right? If you get involved with a high temperature, but you get outside the norm. You gotta think, read the fine print, think a little bigger, think outside the box. A cool flush line is required, and we recommend it for over 225. So stuff to understand here and consider. Here's some options that when I did the FI presentation, the base mounted one, I probably had some pictures of these. I didn't include it in today's presentation, but I see this in specifications too. These are filters or separators that help keep the internal fluids that are going around the seal a little cleaner. So it's some stuff to consider there. And again, I tell you, a 5, 10 horsepower motor, 15 horse, boom, boom, you're in and out, and it's not a big deal. But you start getting into 75, 100, 150 horse motors, it's a different animal. So sometimes you may want to protect yourself as well as the project, and include that in your specification, or at least talk about it and get some more information from your manufacturer's rep. Hopefully it's your TACO rep. We have the best in the industry. Our TACO reps are the best in the industry, bar none. And that's not because they work for TACO. Anyways, we have a great set of reps. So, but learn from them or learn from who you trust to get more information on that, so they can answer those questions even better. So I do want to touch base on the self-sensing pumps. Okay, and here's some pictures of them. And so there's a drive mounted right to the pump. So not just our verticals, but I'm going to concentrate on the verticals today. We have what we call our SKS and SKV models. SKS and SKV, self-sensing, KS, self-sensing, KV models. So that drive that mounts to that is an intelligent drive. Way more intelligent than me. But it takes a lot of work for it to become intelligent. It does have internal programming, but we've had to test that pump and impeller and motor in our lab, our Hydraulic Institute certified lab. By the way, kudos to our lab folks back in Cranston. They just were recertified by the Hydraulic Institute for another 2 years. I seen that email recently, a couple of weeks ago. Congratulations, Joe and your team. But nonetheless, so we put these pumps into our test stand, and we run them at different speeds, take all the data flowing head and whatnot, put it into the lookup table that's embedded in the pump, and now that pump is going to stay on the curves. And we have a whole hour presentation on demystifying these self-sensing pumps and even getting them into more details on them. But I tell you, this is becoming the wave of the future right here. And some of our competitors push it even more, as much, if not more, than we do. And it's an integral drive. It's intelligent. It's going to help you help the project save the end users, save money. You're getting everything. The installer is getting everything from one supplier. Boom, boom. Easy to start up, or a lot easier to start up. So something to consider there. And again, our manufacturers reps have a lot of more information on this and whatnot. So I even see some folks specifying these. Let me get a sip of water here. Sorry about that. So I've seen some specifications out there where they like the package so much, an engineering firm will specify a SKV or SKS smart pump, whatever you want to call it, but not use the self-sensing feature, which you can do with these drives, and still input the signal from the from the transducers out in the system. So that can be done as well. So that's another consideration. So it's something to consider there as you start looking at things. Someone asked, is there a horsepower limitation for that intelligent controller? The answer is no. I think the biggest we've done to date is 300 horsepower. So we don't have them all on the shelf, but we can get up to bigger if required. So something to consider. And again, integrated pump and drive that automatically responds to system demand changes. So as valves open and close, that pump, without any external wiring coming into it or anything, is going to speed up and slow down as it goes. No remote sensors, no complex wiring. Another nice feature, it's like a flow meter because it displays flow and head right here on that screen, which it measures and displays it right there. I've been in some mechanical rooms, and sometimes that's one of the hardest things to find is that and whatnot. It measures the actual system resistance as well. It's hard to see here, but our product, which is a little differentiator from some of our competitors, we actually have vibration isolators here. A good friend of mine that works in the R&D department, Steve, did some testing on this and was worried about the vibration that these pumps, at different speeds and whatnot, would cause on the drive. So he had us put in a vibration isolations here, and now we're well below the rating that the Danfoss, our partners for this drive is Danfoss. I'm sure most of you know that name, but nonetheless, we're below their rating there. And there's a procedure to allow you to self-balance. I'm not going to get into that detail. We cover that in another presentation, but it is available. And with the click of some of these buttons on these screens here, you can balance this pretty easily. Pretty easily, right? But if you've been through it, or some of my folks, good friends, have been through it, and whatnot. Chris asked, can these be rated outdoors? The drives can be rated outdoors, yes. There's different enclosures for those. So yes, they can be rated outdoors. Right now, okay, let's get going. So here's some of the, I call them tidbits, okay? KV pumps can be mounted, up to 15 horse can be mounted horizontally. KVS pumps cannot be mounted horizontally. So that question comes up every once in a while. Smaller pumps, right? 15 horse and below, KV, the direct couples can be mounted horizontally. The KS pumps cannot be mounted horizontally. So keep that in mind. We have seen some pumps with smaller motors may be suspended in the piping, okay? But you gotta make sure the piping's supported properly adjacent to the pump. So just keep that in mind. You can support it or install it inside the piping. I've seen them installed in different spots, and I'll show you some pictures of that. For larger motors, the pump should be attached to a supporting utilizing the tap holes that I talked about before, floating at the bottom there. So keep in mind. Piping loads, this is so important. This is important for all pumps, shall not be applied to the pump. So, the pump's got to not take any of the loads from the piping. So that piping has to be designed properly with the proper pipe hangers all around. It needs to be allowed to move with the piping, so it can't be hard bolted. That stand can't be hard bolted down. So don't rigidly connect it to the floor. And this is, I can't emphasize this enough for any pump installation. Always start piping from the pump. right? I know it's difficult, right? A lot of times the piping's done first, and then you put the pump in, and you got to line things up. You know, the big screwdriver, the big crowbar isn't the way to a final alignment. So it really should start at the pump. I know that's a great statement for the manufacturer to say, but you need to take that into account somehow when things are being installed. You contractors out there, listen. If eccentric reducers are used on suction, flat side on the uppermost, and then that way you still get the nice smooth flow into the pump, right? Nice smooth flow into the pump. And then very important, the last tidbit on this page, don't cover the motor with any insulation. Don't cover the motor with any insulation. Pretty, you know, a lot of this stuff is probably makes sense or easy to understand, but nonetheless, it's good there in that regard. Come on now, why is my screen not going? So here's some pictures of potential, and these are all in the instruction manuals you can download from our website. Unfortunately, I tried to put them up as attachments, excuse me, as downloads, but for some reason it didn't work. I don't know what happened. I tried twice, but I just failed miserably again. So you know, I have seen people support them like this in free, so up to 10-inch flange size. You can install them directly in piping system with no additional supports, as long as the hangers, you know, hangers are sized correctly. And then here's some other pictures for 15 and below, up in the ceiling or up off the floor, with all the piping systems there. You can see the different arrangements there, and not unusual, right? The suction diffuser attached right to the suction side here. Although a good friend of mine, Greg Case, told me it's probably one of the worst things ever invented for pumps. Sorry to quote you on that one, Greg. They work great. They work great. They're installed on projects on a daily basis, but nonetheless, they are there. Oh, by the way, one little tidbit about the Taco suction diffusers. It does come with a startup screen. So there's a perforated screen in there with big holes. That's to keep, you know, cans and big stuff out of the pump as the last line of defense. But for startup, we include, and it's right in our instruction manual for the pumps and the suction diffuser, a very finely meshed screen. I didn't say that quite right. That needs to be removed. Prior to commissioning. Okay, so it's there for startup, because during startup, you know, the first couple of flow through the water, there may be some debris in there and whatnot that needs to be taken out. So keep that in mind. But you can kind of see some of the different piping arrangements that are here. Larger pumps, larger than 15 horse, you know, you've got to start supporting things on some isolation pads and whatnot, and always, you know, make sure it's done correctly. And again, hangers support the weight of the filled piping, pumps, and fitting. You know, very, very important. That is so important there. And again, it's not to the floor here, so you can clean. Maybe you can clean it a little bit as you'd like. You know, you can save some more space. That's another reason why some people look at these KV and KES pumps or the vertical inline pumps. There's a good possibility that they should save space in the mechanical room, which, you know, space is money. Maybe you could put 3 other pieces of equipment in there, right? That's what people will do instead of giving you room for maintenance and walking around it. So nonetheless, some stuff to consider there. And then, you know, where ceiling support is not practical, you can support it. Saddle supports putting down straight down here. Looks like there's a little, obviously you need some straight run of pipe. So you know, it's going to take up a little more room, but nonetheless, we do see that water maybe on a cooler tower base or near room elevation, you know, where ceiling support is not practical. So if you look through our instruction manuals, you can get some more ideas on stuff like that. Here's one, you can see it with the stand. So you can put the stand on a pad or directly onto an isolation pad. So stuff to consider. The pump should not be rigidly attached to the weld to the base pad structure unless flexible couplings are used. So it needs to move, right? It needs to be able to move in there. So you gotta make sure that's in your specifications, or on your walkthrough, you make sure you understand that when you start approving these, you know, the project, or sign off on it before you go. And whatnot. So really, if you know, if you want to have a take a rep go with you on the walkthrough, I'm sure they'd be happy to do that. And you know, can help. You know, I'm one for education, right? I like to learn something new every day. I'll be 63 tomorrow. Tomorrow will be my birthday. 63 years old. Holy moly! Can't believe I made it. But nonetheless, that's not true. I'm in damn good shape for an old fart. Thank you, Alejandro. So something to consider in that regard. And these are cast iron ASTM 48. So the pumps are made of cast iron, the pumps themselves. So there's some more stanchions. Someone was asking about inline discharge flanges. If it's done properly, you can do that, right? You know, it's just you got to, that detail's got to be there. Bolting to the floor, husking pad is not recommended though. So again, that's isolation pads, but some ideas there. You can do that right there. Here's some more maybe seismic. So you can work with TACO or your rep or somebody. We can help do some seismic calculations for our pumps. So that is something. Again, you got to go through your TACO rep, and there's a way they can talk to our engineering staff to make sure that's all done the way it needs to be done for maybe for a project out in California or other places, not just California. Excuse me. And then again, some more pictures here. You know, some more details. Feel free to copy this detail right here and put it on your MEP drawings or whatnot. You know, that'd be good. So here's you know, I'm not going to go over all of these. This is really the problem analysis. It's in our book. So you know, instruction sheets or you know, you open up instruction sheets and on stuff at home, and there's always a problem analysis. So you know, it does give you some ideas to at least check out before you make the call or whatnot. And some of it's kind of practical, but nonetheless, it is important to at least be aware that information is there. All right, so I can't go to these two videos, but take a picture of them. You'll have the recording tomorrow or whatnot. But one's a YouTube video, another is directly on our TACO website. But they both show you how to change the seal on the KS pump. It's on this KS pump that we're used in the demonstration is on a table, so it's not in the field. But the actual functionality, what you have to do, is shown on that. It's pretty straightforward. I mean, you obviously you got to take the coupler off, right? That aluminum machine piece, you got to unbolt that and separate that. It splits down the middle, so that's pretty straightforward. Never lose your parts, right? That's what I'm known for at my house, right? When I take things apart, I got to make sure I put them in the right spot so I know where they are to put back together. But nonetheless, you take that apart, and then you got to take the cover off. You have access there, so you know you need the right instruments to do that, and that gives you enough room to lift it up and get access to the seal. You know, and you got to watch the video because you do have to be careful. And there's some suggestions in there for maybe some little lube or grease in a couple spots to help you slide things on and off or whatnot. But nonetheless, it's pretty straightforward. But you know, I think it's nice to at least be able to have that opportunity. And that's one is on our website, and then TACO does have a YouTube. I don't know if it's channel or whatnot section on YouTube, so you can do that as well. Best in efficiency. Many of you have been around a long time and probably aren't used to hearing that from TACO, but we are the best in it. After the Department of Energy had us pump manufacturers redesign our pumps or look at it to really, they wanted to get rid of the least efficient 10 to 20% pump models out there and have us all improve our design. So from an efficiency standpoint. And this big glob that's on that sheet of paper or that graph in front of you shows you that TACO, for a lot of the sweet spots out there, has the best efficiency pumps out there. Upwards of over 80–85% for the vertical inlines, the ones I'm talking about today, and over 60, close to 65% for the base-mounted FI pumps. We're very, very proud of that fact, and kudos to our R&D department. Excuse me, I had to take another sip of water, with their efforts of putting that all together in that regard. And I get this question every once in a while, which model is more efficient? FI/base mounted or vertical inline, KB, KS? I should say CI, FI, but because we have the closed couple in that model as well. And I think the thought process out there for many moons, many years, was the base mounted had an advantage of a couple of percent. And it really had to do with the recirculation and the path that the water has to take to get out of the casing into the piping. It's a little more straightforward for one compared to the other. But our R&D engineers did a heck of a job when they re-looked at the vertical inlines, and now I can probably say that if you go to our website to pump selection and you put in 500 GPM at 50 feet ahead and you say FI or KB and you start hitting select, you're going to see efficiencies that are very close, within 1% of each other. And for some design points, I see the verticals are more efficient, and some design points, I see the base mounted more efficient. So, when people ask me that question, it's not a cut and dry answer anymore. For us, for TACO, for the green guys, right? The color of money, the green guys. So, something to consider there. And here, if you ever choose TACO as a basis of design, you can go to our website, and feel free, by the way, to include this in your website, in your MEP drawings, on your drawings, in your schedules. But I got this. I made a copy. I didn't take a picture, but I copied it right from the data that I got from our pump selection tool. Right on our app, and if I have time, I'll go to the website. But that's really not, pump selection isn't really what we're talking about here. So nonetheless, boom, you can put that right in and copy and paste, and the work's done for you. As a matter of fact, if you have a good relationship with a TACO rep, I recommend you do that. They'll do all the work and send it to you. So something to consider there in that regard. They'll send you this schedule so you can put it right in. And I know many of them personally out there, and they'd be happy to do that. Another differentiator, and this is on all of our commercial equipment, is our Elite TACO connectivity. And it's these little, you can't see them here, I'm going to show it on a different thing, but we actually have, let's see if it comes up here a little better. It's a tap NFC tag for product info and support. So on many locations, and this is a vertical pump over here, on many different locations on these pumps, there's an NFC tag. And if you take your smartphone and you have the TACO app and you put it over that NFC tag, it is going to bring you into all of the documentation, such as product profile, right? It's going to give you all the information about the product. It's going to give you a recommended spare parts list, or I shouldn't say recommended, but the spare parts information with that. It's going to give you the sales rep that did it for this particular project. And then you can actually download CAD and Revit files, or get them emailed to me. Excuse me, you can't get them downloaded. You can get them emailed to you. So some stuff to consider there as you go. And then it does have our information there. And by the way, if you call during normal business hours, we are one of the few companies, very few, not just in our industry, but across the board, that actually has people, live, regular, good people that answer the phone at our facility. Hello, this is Carla. Hello, this is Brett, or whatever. They answer the phone and they get you to the right person or whatnot. So, but so you do have that, or you can ask Keiko. I get these questions emailed to me sometimes. Most of them go to our technical support team, bar none the best in the industry, but nonetheless, so it's really, I mean, I work for the commercial division, but we sell, many of you know, if not all of you know, we sell smaller circulators or 007s, right? That's a product number that many of you know. So a lot of these are on homes, and some of our guys get calls from homeowners trying to service without calling, a maintenance guy to come over to their house. So they'll get calls from a homeowner trying to fix his pump or fix his little circulator. So, anyways, they answer the phone. They'll talk to you in that regard. DOE requirements. This is sort of old news now because it was required at the beginning of 2020. Man, imagine that 2 years ago. But nonetheless, our KS pumps up to 200 horsepower. Excuse me, do only for 1760 and 3500. The 1250s don't need it. The 1200s don't need it. RPM, they are DOE certified. So this is another whole presentation. We don't give this too much anymore. All of us pump manufacturers have to do that. So when you start, here's one of those E-Link tags down here, one that's not covered up. So it's just a green tag that has all that information on it. But nonetheless, you should by now see this information on HVAC hydronic pumps between 1 and 200 horsepower, not just green ones, red ones, blue ones, whatever color. This information has to be on there. And this was all given a directive by the Department of Energy, labeling requirements. And again, I'm not going to get into the whole discussion on that, but nonetheless, all of that information has to be on every pump manufactured and shipped from a U.S. Manufacturer after January 2020. And I think there was January 27th, but January 2020, what was that information? So stuff to consider there. This is what I tell people, to cover yourselves. Just put a simple line in your specification. All HVAC hydronic pumps that must meet DOE requirements, and that way, if for some reason you go on a project that's not there, you've got it at least spelled out in your specification. So, anyways, I like things simple, right? I like things simple. One option there. I talked about our impellers, so I do want to at least show you some pictures of our impellers. This is a lost foam impeller over here, very smooth. Domestic sandcast over here. There's another lost foam, offshore sandcast. So they come in different ways. You can kind of see the difference, right? The very, very smooth. Because of that, like I mentioned earlier, it does help our efficiencies jump up. And here's the process. I'm not going to spend that much time on it, but the tools are made of aluminum, repeatable, no wear. So they inject foam into it, and so each piece is identically dimensionally identical. If you think about some of the castings, from the traditional ways, they wear, the patterns wear over time, so you may start losing some of that dimensional identical. It's not identical anymore, and so we have or our vendor has the process that does that. So we have a bunch of these as little handouts at our factory when folks come in, and that's all it is. It's a foam piece. So that's the impeller, and then they get put onto a rack like this, dipped in slate slurry. Excuse me. Not slate slurry, clay slurry. to harden them, and we let it dry, or they let it dry, and then it's investment capping. So the foam is vaporized and replaced by molten bronze. Very, very repeatable, no tooling wear, higher efficiencies and hydraulic performance. So I did want to at least touch on that. And, you know, Sandpack, anyways, I think I've spent enough time on stuff like that. Here's some basic rules of pumping. Before I get into trying to answer the questions that are there, always try to keep the suction piping as short as possible. Suction pipe diameter should be equal or greater than pump inlet. So don't go from 4-inch pipe up to a 6-inch. Boy, I got a tickle in my throat. This is where I could use Rich, talk for 2 minutes. Excuse me. And then, you know, a straight run of pipe or a suction diffuser, so important. I mean, there's different trains of thoughts there. So, but these pumps do not like swirling water coming in. They want laminar flow. And I don't care if it's a red one, a green one, or a blue one. They want laminar flow. Watch the elbows on double suction pumps, right? You want the flat at the top. And then just keep that in mind. And then air pockets, right? You know, sometimes you go to a job site and you'll see an up and down right before the pump. You're just asking for trouble there. Air into the system is going to cause issues. And then support the piping to ensure it does not cause strain on the pump casing. So other things to consider there. Pressure gauges. I don't think you can have enough of them, right? You just can't have enough pump pressure gauges as close to the discharge and suction and discharge, at least on one side. We can't emphasize that enough. Put it in your MEP drawings, put it in your details, add it in there. It just, sooner or later, there's a good possibility on a project, maybe not every project, but on a project, you're going to need that information, or somebody's going to need that information. Excuse me. And it's easier if it's there, right? You don't want to start changing things once it's in the field. So, you know, stuff to consider. Always, if you're going to have flow control, which most of us do, put the valve on the discharge. Don't put a control valve on the suction side. You're going to starve the pump. You're going to cause issues there. All right, never use it on the suction side for this bit. VFDs, what is it, 85 to 95% of projects have VFDs. Now, what is it, over 5 horse has to. So keep that in mind. You could trim the impeller. We don't see that too often, but you know, there are cases out there where people might suggest you trim the impeller. So that in that regard, you know, if you're going to put a VFD on, do you need a trimmed impeller? Well, there's different thoughts on that. I don't want to get into that whole discussion. We talked about that during VFDs. My feeling is, as long as the design point is close to maximum impeller size, you know, maximum trim, I don't mind using the VFD with a full trim impeller. That gives me some flexibility there. But if that design point is maybe below halfway down the impeller trim, personally, I would maybe go in a different direction and trim that impeller to some value. But nonetheless, that's another whole discussion. Talk to your folks at your company, or take a rep and get their opinion on that. I think there's 2 sides to that. There might be 4 sides to that discussion in that regard. Gate valves are nice. Nothing gets hung up. Very little resistance to flow, and they provide a tight shutoff. I mean, butterflies are used a lot, but they do add a little resistance, right? More than a gate valve. Gate's almost wide open, or pretty much is wide open, and sometimes they do. There's a hang up, you know, something can get stuck in there. So that's something to consider in that regard as well. Let's see. Like, I can't emphasize this enough. Turbulence and friction, no. No. So it's going to wear on the life. It could cause MPSH issues. It's just going to be, you know, the pump is not going to last as long. the bearings, the seals, and everything. So stuff to consider in that regard. This is a great statement. Thank you, Carmine. Shame on me for not mentioning that. When I talked about pressure gauges, in addition to putting them on there, make sure it's the right correct scale. What do I mean by that? Well, if you have 50 GPM, don't use a 0 to 500 flow. You won't see it. Use one 0 to 100 or 0, use the right scale, the correct scale for the, make sure that's spelled out, or make sure on your walkthrough that that's out there, or else it's almost worthless if it's not. So that's a great statement. Thank you for mentioning that. Bingo. Wow. Did a lot of talking today. So let me see if I can answer some questions here. And I apologize if I didn't get to them as we did. We got some time here, so type in some more. Got a few minutes. Does TACO publish or make available reliability data, mean time to failure, and such? Some of our reps do, but we do not publicize that information, Joel. So there. We have some good ideas. We do on some of our products, smaller stuff, because they're of the approvals that we have to get for them. They're on life tests, so we know a little more about that. But for the big pumps, we don't publish that. Those multiple parallel pumps will have integral to each, or can it be done for multiple? For multiple. So I think this question came up when it had to do with the self-sensing pumps, and currently our self-sensing pumps are standalone currently. So we're working on correcting that, but right now that's not the case. Is there a sizing sheet that can be downloaded? Oh, I think he has left, but I'll answer that question anyways. There's not really a sizing sheet that can be downloaded, but I'll go to our website. Will we be able to define the shaft grounding also, or do we need it for higher horsepower pumps? Great question. I'll get back to the sizing sheet in a second. Shaft grounding, I should have mentioned this. I apologize. All of TACO commercial pumps now above 3 or 5 horse come with shaft grounding rings, and what they are is they protect the motor from stray currents from drives. And I highly recommend that you put that into your specification. Pump manufacturers will not warranty a motor if there's a variable speed drive on it and there's a failure because of that drive. Drives send currents and signals and stray currents throughout the system. If it's not properly grounded and whatnot, it can cause an issue. Yes, Ali, define the shaft grounding. Also, you need it for horsepower. You need it for any pump with a drive on it, in my opinion. So we have chosen to standardize on that, unless somebody chooses not to take us up on that. So someone asked about, hold on a second. Someone asked about a sizing sheet. We really don't have a sizing sheet, but if you go to tacocomfort.com, selection tools, pump selection, and standard pump, you start putting in flow and head. Let me just put in one here and make one quick selection. And then I obviously did vertical inlines, but you can see all the other choices you have here. So we don't really have a selection sheet per se, but that's how easy it is, right? And I mean, if you know your flow and head, you can put that in very quickly. And if you've sat through some of our other classes where Rich does a heck of a job about which pumps would he select or whatnot, and then you can look at the curve a little bigger and whatnot. So we don't really have a selection sheet, but we do have that as a possibility. So let me see if I can get back to the class here. Holy moly, did I end the class? Uh-oh. Shoot. Couldn't have ended it. Here it is. Maybe I'm closing some stuff here, but anyways, it's time for me to say goodbye. I do want to say thank you to everybody that participated. Remember, a couple of days from now, you'll be seeing I mean, 24 hours from now, you'll see look at my messy, let me bring this back up just so I have something that's nicer looking anyways. You'll get your recording and your video. Some stuff to remember there. Any other last minute questions? You're welcome, Sherry. I hope you enjoyed it. Thanks everybody. Take care, and we will see you down the road. Bye, everybody.